This session is about public open embedded builds on 96 boards, basically. My name is Andrey, and I'm TI assignee to LHG. So my main task in LHG is to support public open embedded builds which could be accessible for everyone, not only RDK licenses like that. And we use the freely available hardware on which these builds could be run. Open embedded builds started more than 1 year ago in LHG, but they use custom distribution layer and were a bit unique thing. Now we are working closely with the builds and build lines, and if you know reference platform builds, you basically know how to use OpenSDK builds as well, because they use reference platform builds as a base. We just add something. And the distro layer is the same meta-RPB, we just add another image to it. All the things being worked on in LHG are placed in meta-lhg layer, which is now relatively thin layer compared to what we have a year ago. Also, these builds run in Jenkins, and they are published to snapshots.linaro.org so that everyone can just use the pre-builds and try them. As there are reference platform builds, we don't want to duplicate the work and only build one image with Chromium, because reference platform doesn't build Chromium images yet. As for the boards, we have 3 boards supported at the moment: Dragon board for NC, Hikey, and TI's Beagle X15. So here are the key components of OpenSDK builds. We rely on BSP layers from third parties. Meta-96Boards layer is used for Hikey support. Meta-Kucom has DB4NC support, and Meta-TI is used to get Beagle X15 support. This is where we get hardware accelerated graphics as well. The builds are based on Morty, but some components are more recent than the ones in Morty. These are GStreamer and Mesa in particular, and they come from Linaro's meta backport layer. It lives on gitlinaro.org. For Opti, we use meta-Linaro meta-Opti layer, which is up to date and currently has Opti 2.3.0. As I said, LHG builds need Chromium, and for Chromium we currently use a fork of Chromium version 45. LHG has done some changes to Chromium, and also we have a plugin to implement OpenCDM. So that's why we use this one. And another component required for secure playback is the AES Decrypter, which is a trusted application, and the recipe is in meta-lhg. So meta-lhg layer is available at GitHub. Linaro Home is the account we use for LHG components. Meta-lhg has, in fact, two layers. Meta-lhg with some specific components developed inside OpenEmbedded. Here is the list. This is the image. Though OpenSDK builds don't have Westeros images, there is a recipe which is used by RDK builds. Here is the Opti-IS Decrypter, and basically that's it. We use a fork of Meta browser with the Chromium version 45, so that's not represented here. I've separated some fixes or workarounds needed to get some components integrated into the build, putting it into a separate meta-lhg integration layer. This is something which should be absent in ideal world, but there is some kind of fixes which we need, and they are here. This kind of reminder that something needs to be fixed in proper way or get upstreamed. Currently, there is not much stuff in this layer which is good, and mostly it's BBIPNs for Western and TI-SGX DDK-UM. This is the userland driver for PowerWare. The modifications to Western actually are due to TI's board. The thing is that not BeagleX15 itself, but a similar AM57XX EVM board, it has two displays, and this is required some changes in Western. So some earlier we have more stuff in the layer which is now meta-lhg, but it was kind of common code, and now it's landed in other layers like meta-96Boards and meta-RPB. This year, actually, in 2016, we've got Mali driver for high key available, and finally it has been added into meta-96Boards. And to have to enable EGL hardware accelerated, EGL drivers supporting meta-RPB, we ended up in having EGL.inc, which is not only for Mali but PowerWare, and it can accept other GPUs if there are any more available. So as I said, our builds are based on Moti. In Jenkins we have two kinds of builds, kind of normal ones and staging ones, which can have some more experimental things in. And even for staging builds, we still use Moti, not master, because otherwise we will end up in having too many packages and applications being updated too often that we would like, as we have particular interest in some areas. That's why we have, for example, Mesa and GStreamer up to date, more recent than in Moti, but for other components we are okay with what is in Moti at the moment. Chromium is currently an issue after reference platform builds and LHG builds has been updated to new GCC and glibc. Chromium stopped working. Now it's fixed, but partially. Not everything can be displayed. For example, YouTube is not working yet. And the question is often arises why we still use version 45. So actually, I tried using the version currently in Meta browser. There is an issue with Ozone because older version of Chromium use Intel's implementation of Ozone, and it's not being worked on by Intel for a year and a while maybe. That's why Google started their own implementation, but it's still work in progress. As the result, Meta browser has split it. They split it, the Chromium recipe into two. The one for X11 uses version 52, and they leave Chromium Wayland recipe to use version 48. This is probably the most recent which has Ozone support. So even if we switch to Meta browser, we won't get very close to upstream Chromium. And I did just one experiment, and in this build, Chromium 48 failed to build. There was some problem with the header file. This can be addressed, but in general, the question remains if we should try using the most recent version with Google's implementation of Ozone, because I'm not sure if it makes sense to spend time on working with version 48. Hardware accelerated playback in GStreamer works on DB14C. It has been broken for Wayland, but seems like the fix is on its go, and we should have this resolved really soon. Actually, I have a fix, but hasn't tested it yet. So here are the links to the Jenkins jobs, the stable build and the staging one. And here are the links where one can find the pre-built images. There are short instructions on how to build images in the README file in the manifest repository. This is essentially just executing these 4 commands. Some people from our team reported issues, but so far they were mostly about having setup not very well suited for open embedded builds at all. So, like they started with a virtual machine with just 1 GB of RAM. There are some pointers at 96 reference platform builds pages about how to get through proxies, if this is the issue. And some standard open embedded setup is needed, including some packages to install on the build machine. This is actually covered on Yocto project web pages, so all in all it should be quite simple if one have a high performance enough machine with enough space of memory. So I think this is basically it. If there are any questions, I can answer them.
So you mentioned that for GStreamer and Mesa, there were more recent versions than what's currently in Morty. Are there specific patches or features that are needed in those for meta backports?
I think the more recent versions were needed by DB410C board. They use they use hardware acceleration, and their code is for kind of most recent GStreamer.
So, just going back to the Chromium recipes and things. So you said they've split the recipes into X11 and Wayland. The Wayland one is kind of further behind.
They have decided to move forward, and they could not move forward with Wayland, so they separated the X11 recipe and updated it to version 52, leaving Wayland Chromium where it was
sort
before.
Of behind, okay. Do we know why that happened? Or?
I think this is the ozone issue.
Okay.
At the previous Connect, there was discussions on Chromium and GStreamer integrations and things like that, and the Aura ozone architecture I haven't been keeping much track, but there is modifications going on there. I think part of it has been built in, but that part is in flux. I don't know if they're going to deprecate either Aura, or one of them is going to be deprecated, and I'd have to look and remind myself which one it is. So once, I think that part has to settle down before I think they can move forward. There is issues with it, and it's something that we want to see resolved at some point. I don't know if there's anybody else here who's been following the Aura ozone Chromium saga, but again, it's something we're keeping an eye on, because that's why we're still on an older Chromium branch. And as Andrey mentioned, for the work we did with PlayReady, we used the OpenCDM with Chromium, so we still have that piece as well. So that's another reason we have like a fork of it, as he mentioned.
So to my knowledge, Igelia, if I pronounce the name correct, this company is working on getting Chromium running on Wayland. They work. Igelia, I misspelled the name. Yeah. I think they have something working already, but just very basic thing. And they expect to have something more usable in the next half of this year, maybe. Okay, so I think if there are no questions, we are done. Thank you. Thanks for attending.